Hello everyone, and welcome to another video of Special Maths Academy. Before I move on, please don't forget to share, like, comment, subscribe, and stay tuned because the next edition of the Special Maths contest has just been announced. So in this video, we're looking at the 16th problem from the Special Maths contest 2024 first round. And it says, suppose P is congruent to 1 mod 12. And then we have 1 times 2 times 3 up to times P minus 1 over 3 is congruent to minus 2 mod P. Then P plus 2 over 3 times P plus 5 over 3 dot 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 up to 2P minus 2 over 3 is congruent to X mod P where X is equals to what. So we basically want to find the value of X here. So something that's important to note here is, okay, so if we have P congruent to 1 mod 12, okay, and then we have that, so we have 1 times 2 times 3 times, so up to P minus 1 over 3 is congruent to minus 2 mod P. Okay. So the first statement I want to prove is that the GCD. So the GCD of 1 times 2 times 3 times, okay, so basically let me just put, in order not to write a lot of long things here, I'll just put P minus 1 over 3 factorial. So GCD of this and P is equal to 1. Okay, so this is the first statement. And then the next statement I'll prove is that P is prime. Okay, so P is a prime number. So P is a prime number. Okay, so let's look at the first statement. How can we prove this? So first of all, we have that, so basically we have P minus 1 all over 3 factorial is congruent to minus 2 mod P. Okay, so this implies that we can say, so we can express this is equal to, so let's say some Kp minus 2. Okay. So next, we want to find the GCD of Kp minus 2. So I want to find the GCD of Kp minus 2 and P. Okay. So this is equal to, basically, you can say this equals to the GCD of, so we can do some reduction, Kp minus 2 minus K times P and P. Okay, so this equals to the GCD of minus 2 and P. Okay, which is, so the GCD of 2 and P. Okay, so the negative number doesn't really play any role in this. But now we have the GCD of 2 and P. What does this give us? So we come back to this first statement that P is congruent to 1 mod 12. Okay, so what does this imply? So this implies that P is congruent to 1. So we can just break this down. P is congruent to 1 mod 2. Okay, so P is relatively prime with 2. So it means the GCD of P and 2 is equals to what? 1. Okay. So basically I've proven the first statement. So let me just mark it with green. Okay, so let's go back. Then the next statement. So P is prime. So for me to prove that P is prime is enough to show that all the numbers from 1, 2, 3 up to, around, so up to the square root of P, so less than or equal to square root of P. So all these numbers are relatively prime with P. So basically, all these numbers, none of them divides P. Okay. So this is one way of proving that a number is a prime number. Okay. So now, basically, this first statement where we looked at the GCD of P minus 1 divided by 3. So this first statement, we've looked at the GCD of P minus 1 divided by 3 factorial and P, and we show that they're relatively prime. This proves that all the numbers from 1, 2, 3, okay, up to P minus 1 over 3. So all these numbers, none of them divides P, okay? So now what we need to analyze, so let me scroll down a bit. We also need to compare, we need to compare P minus 1 divided by 3. So compare P minus 1 divided by 3 and the uh, floor function. So this basically is the floor function, the integer that the greatest integer less than the square root of P, okay? So that's the floor function. We want to compare these two things. But we know that this the floor function of square root of P is less than the square root of P. So let's just see if we can compare these two things. So we want to compare P minus 1 divided by 3 and the square root of P. So if we can show, so basically, scroll down. Okay, let me just erase this, what we have here. Okay, so scroll back up. So basically, if we can show that the square root of P is less than P minus 1 divided by 3. Okay, so if we can show this, then it means this statement here. So let me call this. So it means this statement implies this. So it means this the statement of 1, 2, 3 up to P minus 1 divided by 3, not dividing P, implies that 1, 2, 3 up to the floor function of the square root of P doesn't divide P. So if you can show this, then it implies that. So I believe that should be clear. So let's look at this. So basically, for the square root of P to be less than P minus 1 over 3, let's square both sides. So we want P to be, so this will be P squared minus 2P plus 1 divided by 9. Okay, so let's just compare this. So we want 9P to be less than P squared minus 2P plus 1. Okay, so basically we want 0 to be less than P squared. So this will be minus 11P plus 1. Okay, so we want 0 to be less than this. So if you look at this, so basically you can just see that, okay, so let me just let me just do some completing the square. So 1, 0 to be less than, so P minus 11 over 2 r squared plus 1 minus 11 over 2 squared. Okay, so we want this to be less than so let's do this. This is going to be 1 minus 121 over 4. Okay, so this is going to be 117 divided by 4 to be less than P minus 11 over 2 squared. Okay, so 117 divided by 4, this is basically so this would be 28. Okay, so they're about 29 rather. But this would be 29.25 basically. Okay, so about this, want this to be less than P minus 11 over 2 squared. Okay, so basically if we have P greater than 12, so if P is greater than 12, this satisfies the condition of this inequality. Okay, so let me let me put it up here. So 129.25 to be less than P minus 11 over 2 squared, okay? So, but if P is greater than 12, this satisfies it because if P is greater than 12, so for instance, uh, let me erase this, or let me just write it here, okay? Erase this. So if P is greater than 12, okay, then 12 less than P, so this implies that, so subtract 11 over 2 from both sides, 12 minus 11 over 2 less than P minus 11 over 2. So this is going to be 20, 24 minus 11, that's going to be 13 over 2 less than P minus 11 over 2. So 13 over 2 all squared. Okay, so this is 169 over 4, which is, greater than 117 over 4. So we see that when P is greater than 12, so when P is greater than 12, then we have this equality. So let me erase this. So I'll just put it, it's an important fact. So P greater than 12 implies that P minus 1 over 3 is greater than square root of P, okay? So now that we have this fact, it implies that, so it implies that 1, 2, 3, okay, up to plot function of square root of P up to, P minus 1 over 3. So all these numbers, none of them is a divisor of P, and as such, P is a prime number. So now we've shown that P is a prime number. What next can we do? Okay, so let me scroll back up so that the problem is in view. So the next statement, so I'll just put it here. So let me mark that we've proven this, okay? So back to this. So the next statement that I want to use is the Wilson's theorem. So Wilson's theorem states that if you have P minus 1 factorial, this is congruent to minus 1 mod P, okay? So this is Wilson's theorem. Okay, so for instance, if you look at 5 minus 1 factorial, that's 4 factorial, so that's equals to 24. Okay, so this is congruent to minus 1 mod 5. Okay, so this is just Wilson's theorem. And look at an example, 7 minus 1 factorial. Okay, so that's equals to 720. Okay, so that's congruent to, so 7 going to this 1. And so 7, yeah, that's congruent to minus 1 mod 7. Okay, so this is just Wilson's theorem. So we can apply this fact here. So it means we have that we have that P minus 1 factorial is congruent to minus 1 mod P. What's the next thing we can do? So now we can just, compare everything. So I'm going to erase this statement at the top here so that we can write some things up here. Okay, so I hope you're enjoying the problem. If you're enjoying the problem, don't forget to give us a like. So now let's look at the problem at large. So for instance, we have 1 times 2 times 3 times P minus 1 over 3. So P minus 1 over 3. So let's understand what's going on here. P minus 1 over 3 plus 1. That is going to be P minus 1 plus 3 all over 3. So this is going to, the next number in line is going to be P plus 2 over 3. Then we keep on adding plus 1. So that's just P plus 2 plus 3 all over 3. P plus 5 all over 3. So this continues up to 2P minus 2 over 3. So basically, what why I did this is so that we can understand that this product here is a product of, consecutive integers. Okay. So it's a product of consecutive integers. So why I say integers, of course, since P is congruent to 1 mod 12, it means P minus 1 divided by 3 is an integer. Okay, so yeah. So now what do we want to understand? How many integers are in this product here? So one quick way to find that out. So to be 2P minus 2 all over 3. So minus P plus 2 divided by 3. So, and then plus 1. So for instance, if you have the numbers 1, 2, 3, I want to find number of integers in this consecutive, listing of integers. Equals to 3 minus 1 plus 1. So you're adding that plus 1 to make up for undercounting. Okay, so that's it. So this gives us, P minus 1 divided by 3. Okay, so 2P minus P will be P. And we have minus 2, that'll be minus 4 plus 3. So this equals P minus 1 over 3. So there are P minus 1 over 3 numbers in this string, okay? And then we just multiply the, up to the, so basically I want to use P minus 1 factorial here. Okay, so multiply up to P minus 1. And by weighting string, we know that this is congruent to mode P. Okay, we know that this is congruent to mode P. Now, what next can we get from here? Okay, so now we can kind of do some sort of pairing. So I'm going to erase this. We can do some sort of pairing. I'll erase this. So now, what I want to show is that 1 times 2 times 3, okay, up to P minus 1 all over 3, okay. So this is congruent to, so we can add we can compare this and the numbers from the back. So this is congruent to, so okay, just do P minus 1, okay, times P minus 2, okay. So we can multiply this out. So we're just counting the numbers from the back. P minus, so up to this would be P minus so let me write this. So basically we're subtracting P minus 1 over 3. Okay. So why are these two numbers congruent? They are both congruent because we have that P is congruent to 1 mod 12. Okay. So that means this is congruent to, okay, so let me do it this way. So let me write it on the same line. So this is congruent to minus 1. So we multiply each of these terms in this product by minus 1. So minus 1 to the power of P minus 1 divided by 3. Okay. Then times P minus 1. So we're writing the product from the back up to a certain point. So P minus 1 times P minus 2 times up to P minus 1 over 3. So mod P. Okay, so let me erase this so that we don't get confused with this. So this has served this purpose. Okay, so we have this is congruent to this. But now, what is minus 1 to the power of P minus 1 divided by 3? Okay, so P minus 1 is congruent to 0 mod 12. Okay, so if you divide by 3, okay, no need for dividing by 3 yet. Let's look at it this way. Let's see like this. So what does this imply? This implies that P minus 1 is congruent to 0 mod 4. Okay, so now if it means if you divide by 3, so we have P minus 1 divided by 3, still congruent to 0 mod 4. So we can divide by 3 because 3 is relatively prime with 4. So it means this minus 1 to the power of p minus 1 over 3 is just equals to 1. Okay? So now it means we have that the product of the first p minus 1 over 3 numbers is congruent to the product of the last p minus 1 over 3 numbers in this p minus 1 factorial. Okay? So it means this term that is congruent to x. So basically we have the first part of this product. So from here, let me use a different color. Let me use black, for instance. So we have this first part. Okay, that was too long. This first part is congruent to minus 2. This last part, okay, is also congruent to minus 2. Okay, and then this middle part is congruent to x. Okay, so basically we have, let me write it down here, minus 2 times x times minus 2 is congruent to minus 1 mod p, okay? So what does that imply? 4x is congruent to minus 1 mod p, okay? So what does that imply? Implies that x is congruent to, so we can add p to both sides. So x is congruent to p minus 1, okay? So 4x is congruent to p minus 1 mod p. So I'll just skip that writing mod p. So this implies that x is congruent to p minus 1 over 4 mod p. Okay. So now all we just need to see that that p minus 1 over 4 is an integer. And of course, it's an integer because p is congruent to 1 mod 12. So p minus 1 over 4 is an integer. And we also need to see that, so for it to be a residue, it's between 0 and p. Okay. It's between 0 and p minus 1 rather. Okay. So, and that's obvious. So, of course, the answer to this question is going to be p minus 1 divided by 4. Okay. I hope you enjoyed the video. Don't forget to like, share, comment, and subscribe, and see you in the next video. Goodbye.